Thank you for having me once again. Very happy to be here. Can everyone see my presentation screen? I just want to make sure as well. Okay, perfect. Awesome. So I'm Ben Olender. I'm a CPHT and a product consultant with 475 High Performance Building Supply. And today we're going to dig a little bit into some of the tricky transitions for air barriers that you might see on a project. I just want to quickly also say for those of you that are not familiar with 475 Supply, we are a full high performance building materials company. From sub-slab vapor barrier all the way to ridge of your roof, we have a material or a system that can help you guys out on your projects. So we have ventilation, air sealing, fenestration, knowledge resources, and now a few other subcategories which you can find on our website. So for most of your projects, your membrane slash air barrier runs will be simple, but it's for these transitions or material changes that will be difficult. As I like to say, the devil is in the details. So today we're mainly going to focus on a few of these connections, primarily the foundation to wall connection, the floor to floor transition for your interior air barrier, and the wall to roof transition. Additionally, I want to note that we also have an expanded video series called the 475 Building Blocks on our YouTube that digs a bit further into some of these concepts. So we're going to start with the bottom for our foundation to wall connection. This is a very common connection which many people are making, but what I want to highlight here is that this is showcasing our Solotex Adhero 3000 fully adhered peel and stick membrane. Here it's adhered to the plywood substrate behind it, and this membrane is airtight, watertight, and vapor permeable. For this detail, they taped the Adhero membrane to a CMU block foundation wall. The Adhero membrane was taped to this and then covered with a vapor closed three-part rubberized material for below grade waterproofing. This is a standard transition that focuses on waterproofing rather than air sealing. And that's because the CMU block wall is not reliably airtight. With the block wall foundation, the grout connections are not airtight. Many people are trying to treat the grout with a fluid applied membrane to air seal the wall, but poured concrete is airtight. Or we have a 15 mil poly sub-slab vapor barrier that we carry at 475 called Stego Home. Plastic poly like Stego is vapor closed and acts as a capillary break to the concrete from the ground moisture and is fully an airtight material. This membrane requires us to tape the seams and seal around penetrations and pipes, and it's one of the very few places on a project where we truly recommend and want a fully vapor closed material. Here in Colorado, where I'm located, a lot of the use of these Stego membranes are for radon mitigation in addition to the capillary break that it provides. In your area, you might not have as much radon in your soil. Here we at 475, we also offer our own sub-slab vapor barrier tape called Compego. Both Stego tape and Compego tape are great for these connections. But what you can also see here is that the sub-slab vapor barrier is run up the perimeter of that wall a bit, where it's meeting that concrete stem wall. This allows us to tape to that sub-slab vapor barrier at a later time and treat it as a primary air barrier for our foundation to connect to later on. So leaving a flap of membrane accessible allows things to be tied into at a later point. This is the concept which we'll touch on many times for many different areas. The concept of a floppy bit is what I'll refer to it a lot as. So many times the vapor barrier is stopping too short and getting buried under the concrete. This is showing that it's running long on the perimeter. Here on this project, they started to install the Intello Plus membrane on the ceiling. That will transition to the wall and connect to this band of poly that's coming up from the slab, effectively transitioning the wall air barrier to the foundation air barrier, maintaining that red line test. We are comfortable with being vapor closed below grade because this is where ground moisture is constant and that vapor drive will always be coming inwards. Once we're above grade, we want to try to dry in both directions. And that's where we use Intello Plus, which is a vapor variable material that dries through diffusion and will allow drying to the interior. So here we are showing another slab condition. Here we're seeing the vapor barrier running long. This is another option to transition your sub-slab vapor barrier to turn it outwards towards the exterior to connect to our exterior air barrier, which might be a high performance house wrap like we carry at 475 or something like Zip, but essentially bringing that interior slab to the exterior to tie into the outside. I don't love this because the poly can get worn down and even torn under these mud sills and bottom plate connections. Oftentimes, this is where I'm recommending you switch to one of our tapes. We have a tape called Exto Seal Phenoc, which acts as a durable, airtight capillary break and sill seal. which can be connected to either side of the wall. So you essentially are encapsulating the top of your stem wall with the tape, allowing you to seal to both sides without having to run your poly under and risk it getting damaged or torn. Um, this is really cool and visible in one of these details, but what this shows is what that would look like once your exterior sheathing is set and your poly is running long. The intention would be taping this poly to your sheathing and then running an airtight, vapor permeable, waterproof membrane over the face of that, and to make a shiplap connection. That might be our Adhero membrane or a Mento membrane, whether you're looking for a mechanically fastened or fully adhered application. In this image, it's just showing our Tescon Vana tape, our general air sealing tape being used for the plywood seams. What I want to note is that taping the plywood seams can be considered a pretty good home approach. Plywood can be airtight, but is not manufactured to be airtight. The thicker pieces of plywood can make for a more reliable air barrier, but for the most part, to effectively reach our high performance goals of air sealing, we are using materials that are manufactured to be airtight rather than materials that can be made airtight but are not manufactured to be. That's something I want to note that's very important. So here you can see the plywood seams being taped and that foundation to wall connection being made with the black tape. This is one of our concrete tapes that does not require a primer. It's called Contiga Solido IQ. If you also notice this white tape that appears in the corner of the left image, capping the foundation wall, this is our Extil Seal Phenoc tape, making the capillary break and that effective sill seal. So your floor system can be set on top of that and you do not have to worry about moisture moving from your foundation wall up into your framing. Uh, this also connects the interior air barrier to the exterior. Important to note, poured concrete is airtight, so providing the opportunity to seal directly to the concrete with an air sealed connection using one of these tapes, like we have shown here. Here we're also showing a double-sided version of that Contiga Solido tape that can stick to concrete. This is called Contiga Solido IQD. In the image on the left, that white line actually shows the face adhesive on the face of that tape. So for the double-sided strip, that backer is still covered. So maybe they're not at that stage yet and are not running membrane. They're leaving that adhesive backer on to protect it. So when they're ready to run their house wrap, they can make a very nice shiplap connection. So if you see in the image on the right, they have pulled that adhesive. They've placed our Mento 1000 fully adhered WRB, or sorry, mechanically fastened WRB to the sheathing, and then overlapped it to connect to that double-sided strip. In the image on the left, I also want to highlight that black paint looking stuff. That's called Viscon. This is going to be a liquid applied, vapor permeable, airtight, but watertight membrane, essentially. So here they use Viscon to seal up the uneven substrate of that stone wall. The grout in this overlap when it goes and meets sheathing is not an airtight connection. So they're air sealing all the grout points and then bleeding it onto the sheathing a bit so that when they run their membrane, they can just tape to this and now they have a good air seal to an uneven and unreliable substrate. So Viscon is a great material to help shore up some of these irregularities, and I call it our tricky situation material because it's good in a lot of places. Great for holes, cracks, joints. Well, something I want to highlight, this is not a below grade waterproofing. It is vapor permeable. So it's, good for anything above grade. If you're using it in your basement or in a crawl space, just make sure that exterior wall is effectively waterproofed, and then it makes a great air barrier that's also vapor permeable. So for pure foundation or unconditioned crawl spaces, we're typically treating the underside of that floor system as our air barrier. We're insulating in the floor and then running an airtight house wrap on the underside of the structure to encapsulate this insulation like we want to do with our walls. This is showing our Mento 1000 membrane being used with batt insulation on the underside of the structure. If you're looking for a dense pack option, we offer a material called Mento Plus, which can be blown directly through at the exterior for roofs and walls. In these images, you can see the floppy bits, which I refer to a lot, of the membrane. They are pre-placed, these strips, so the membrane can run continuously under the building between the framing. We would then want to connect those membranes to one another and turn the adhero, shown here in blue on the side of the building, down to the underside of this floor system. The adhero is a big peel and stick, like a big piece of tape, that's airtight, watertight, and vapor permeable, self-seals around fasteners, so all they'd be doing there is pulling that last adhesive strip on the bottom and then just folding it to the underside of the structure, making for a really continuous run. Um, so for pure construction, you could be using the same WRB for the walls for the underside of that floor. If this was an unvented crawl space, it's best to use a lower vapor perm membrane. We carry ConstaVap Plus, which is a membrane that has a consistently low perm rating to act as a vapor retarder. So very scenario dependent on which material to use, but the general concepts for how you would get continuity is what we'll maintain among material choices. So that discussed some of our foundation connections, and now I want to dig into floor-to-floor transitions. Transitioning our exterior membrane between floors is easy since the membrane is not interrupted by the floor system. But how do we do that for the interior air barrier where framing might interrupt a continuous run? This is where sequencing becomes very key. So I want to start with this. The easiest approach being covering the top plate with a tape or strip of our adhero membrane. This is now creating an airtight surface. So now if it goes to the inside and to the outside, you can stick to either the interior or exterior to get an airtight transition. So moving to the next image, we see that they're using OSB as their rim joist, and you can see the LVL floor system in the background. So they're setting everything on this piece of tape, allowing them to seal to it. So in this next image, you can see they're taping on the exterior side. As you see the Mento membrane connecting to this band of adhero at the top of that wall plate or top of that top plate, and then taping from that exterior rim joist in to get an interior tape connection above. Another way you can do this is putting the floor system on ledgers. So this would, it's a different style of framing. It would take a different slew of planning, I would say, to traditional construction from what I'm seeing. But this would allow you to place the Intello Plus continuously inboard of your floor system, and your floor system be set on ledgers inboard of that. This simplifies things, but is a sequencing concern as your framers would need to know where to pre-place all these membranes before they bury it in framing. So much of these sequencing processes are a conversation with your trades, getting them to get material on site at the right stages, because none of these things are very hard to do. It's just making sure you do them at the right time to make it easier later on. So without sequencing, it becomes pretty labor intensive to tape and seal around all these framing members. Here's a retrofit where a strip of Intello Plus is being placed and then metal hangers are being used to support the floor. This works well, but I'm worried about the Intello getting damaged during construction for a detail like this. We do offer a commercial grade version of Intello, which is called Intello X. It's a bit thicker than the Intello Plus and could just handle the wear and tear for a connection like this a bit better. So sometimes for these floppy bits, I am recommending the commercial version to use as these strips. The most common method I am seeing done on site is where the rim joist is being wrapped. This is placing a floppy bit of membrane on the top plate of the wall before the floor system is set on it. The membrane is then turning to the outside before briefly coming back to the interior to connect to their Intello on their walls. So in the image here on the far right, excuse me, that blue line theoretically is a piece of membrane. So where that red tape is, that's connecting their floppy bit that's going between floors to their wall membrane. So that might be Intello. So they're able to bring it up, out, up, and around. So here's a good visual image of that with the adhero on the left. You can see the membrane coming up the interior wall, turning to the exterior, and coming back in. And they're using this as an air barrier transition. And since this isn't encapsulating the insulation, we're just more focused on the airtightness of it. I'm not as worried about vapor variability and drying potential for this one type of detail, given that it's framing butt up in there. This approach works very well, but it does get tricky around the corners. I've had to give advice on how to do this taping method. It is a nightmare to do in practice. I push people to not do it because it's a nightmare. So the floppy bits are great for the straight runs, floor to floor, but when it gets to the building corners, this is where I'm recommending you use a piece of tape or a piece of membrane like our Hero that sticks. And that makes it real easy to encapsulate all of the rim of this floor transition. So all you have to do at the floor below is access the floppy bit hanging down to your interior wall, tape to it, and then do the same for the floor above. So you have a band, a transitionary band between floors. They also could be multiple pieces of tape covering the top plate, then connecting from that top plate to the rim joist, and then they're turning that in and taping to the subfloor. So the interior air barrier briefly turns to the exterior, but is still airtight and continuous. So this is showing that connection here. They stopped their sheathing just short of this so that they can tie in at a later date. But if you're unable to do a floor-to-floor transition with many projects like retrofits, or you decided to do this later on in the planning phase and can't make adjustments, which is fine, you could certainly just air seal around those beam penetrations. On the right, they are taping around the floor joists, which is laborsome, but easy to do. On the left, they're showing what it may look like if you forgot to tape around these beams. Viscon, or one of our liquid applied membranes, is used here to seal up and connect to the Intello at the top plate and continue that connection to the subfloor above. So essentially avoiding having to do something like this. Again, very possible, just labor intensive. These I-joists have lots of edges to tape around. You'll be sticking tape into lots of fine corners. Again, very possible, but a lot easier if you forgot to just put a liquid applied up there. Given that all of our tapes and adhesives stick to this cured membrane, the cured Viscon, you can use it as a transitionary material. So this is where I might recommend you spray it up in the rim joist and paint it down or spray it down the wall to an accessible flat piece. So I might say, do it as they show here on the left, and then just paint a band of it on that top plate where your Intello is sticking to. Now you don't have to tape your Intello up in between every one of these bays, which is what you see here. So again, doable, but labor intensive. These are the types of little tips and tricks that save on the labor side of things when doing this for the first time or for your second or third, for example. So here on the left, we're showing a retrofit where a party wall was treated with the fluid applied, and then the beams were sealed off with Tescon Vanna one by one. The image on the right shows that same connection being made, but through an I-beam. You can actually see the condensation on the underside of that I-beam if you look from it being a bad thermal bridge. You see some water droplets actually. You can also see it's a bit more of a mess of tape as well. So, there's a lot of tape overlapping. It's hard to tell if there's an air leak, where a weep hole might be opening up or something of the sort. So to try to avoid some of these complicated tape connections, that's where a liquid applied could be useful, or just detailing well beforehand. Uh, Go back. Something I want to highlight on the image on the left is actually, where did it go? There it is. Yeah. So the image on the left, what I want to highlight is that there is a seam running the length of those two sistered beams. So the issue with that is that that seam will follow to the exterior and actually be an air leak. But how do you address an air leak that runs the entirety of a beam? Well, you would actually intercept that penetration. So you would drill a hole in the beam in the area you're looking to air seal. You would squirt in some of our one of our liquid applied or airtight adhesives. This is the Contiga HF. The image on the bottom left, the number 4, has a question mark because it's just, showing a scenario. How would you get it far into that crack if it's 12 inches deep or much further, obviously? You'd use a straw, essentially. Just put a straw on the end of it, and then you could get in there a bit further. But what this allows you to do is that when you seal up, as you see the Tescon Vanna in images 4 and 5, when you tape over that seam, an air leak, is no longer continuing under the tape. It stops there. So now you've effectively terminated that air leak and begun your air seal, even though it might continue into the building further. So for interior air barrier, a lot of what I'm concerned about is just sequencing concerns. None of these techniques are very hard. I mean, we discussed the rim joist, how you would maybe go between floors, but in a typical just, level 1 construction, you are only doing the first floor right now and you want to start partitions. If you intend to do an interior air barrier, something important to think about is your partition walls. For our red line test, we only care about the shell of the building, the envelope. The partitions, we don't air seal. We just want to make sure they're inboard of our air barrier. So this is what that may look like. If you are unable to, hold off on your interior partitions till you're fully dried in, that may look like putting a floppy bit or a strip of membrane behind this, pin it to the framing to then tie into later with a piece of tape. This is what that may look like if you're able to get dried in before framing this partition. So in this project, they wrapped all their exterior walls and ceiling before they put up their partition walls. They also put strapping, which allows for a service cavity, so they can run their utilities inboard of their air barrier above their framing of their partition walls without interrupting their IntelliPlus membrane. So this is real neat because then they could run some utilities. They pinned their partition walls to these strapping boards on the ceiling and walls, and it just makes for a very clean install with a lot less detailing for your further trades like electricians and whatnot. For those of you that are not familiar with the service cavity, It's essentially strapping inboard of your interior air barrier, which you will then put your finish on. So your drywall would sit on the strapping. And the intention is, for two reasons. One, that your utilities, like your electrical, would be mounted to the face of this interior framing, so that the depth of that ideally would be the depth of your electrical box, for example. So you're not having to use a gasket or air seal at every electrical penetration through this membrane. It just lessens the amount of air sealing you'll need to do that's inevitable anyways. So I push for this in addition for interior finishes like drywall. It's less penetrations for the actual drywall into your Intello. They're ideally going into these framing members as well. Here's just showing another transition from ceiling to wall. And it's bringing the Intello Plus down past that double top plate because that is an air leak. You know, if you're not sealing that up with an adhesive or at the exterior. So they're just bringing their interior air barrier down past that and making that connection there. And the image on the right just showing it being pinned up above another roof framing. So lastly, I just want to talk about the wall to roof transition. This is a very common one and is a big area of difficulty on many projects, just depending on where you're locating your air barrier and where you neatly transition that to the inside or to the roof, for example. This is the Monopoly framed home. For those of you that don't know, it's called Monopoly framing because it looks like the Monopoly homes on the little board game, where there's no overhangs. This allows for continuous run of your exterior house wrap and WRB from wall to roof. But this alone, as you see here, the image on the right and the image on the left, it's the same membrane for the wall and the roof. That's very unique to 475's materials. Many of the house wraps on the market will be microporous membranes. They will rely on micro holes to allow bulk water to run over the face of it, but vapor to push through. This is great, but does not leave for a very reliable or airtight or watertight material. This is why you're not seeing the same house wrap for your walls also be used on your roof. They have a different membrane for that. With 475 materials, all of our house wraps have a monolithic uniform film. So it dries through diffusion and there's no microperforations, which allows this membrane to be far more airtight and watertight, which lets you use it on the walls and roofs continuously. So less products on your project. We all love that. Less things to have contractors confused by. We all love that. So this certainly simplifies things. And um, we still want to apply overhangs. We still want to kick water off of the building. That's not to say that we don't, but it's just the sequencing of when you'd put them on, which is helpful. This is a really cool detail. It's pretty custom, I will say, but they custom cut all of these rafter tails, and this is what we would call after applied rafter tail. So they notch cut all of these and cantilevered them, mechanically fastened them into the edge of the roof. So then they can tie in and build off their overhang off of that. The cool thing about this, which I love, is that they really planned this out with the depth of that notch. So if you look on the image on the far right, it maintains continuity with the depth of their ventilation and drainage plane, which they're using strapping on for the remainder of their roof. So it leaves for a nice continuous design. And if you aren't able to do after applied rafter tails in this way because maybe it's labor intensive or maybe just difficult, this is showing another version of that, where it can be applied on a ledger board on the top of the wall, excuse me, on the top of the wall plane of the range screen battens. What I love about this is the ledger is outboard of the range screen, allowing drainage from wall to roof. If the ledger was directly against the house wrap, the vented cavity would be interrupted and we would need to flash the top edge of the ledger framing, just much more detailing if you put it against the house. Kicking it out onto that strapping saves you a lot of extra detailing. Here's showing what it may look like to seal around these overhangs with tape. Probably a lot of the current projects you guys may have worked on, if you haven't done some sort of sequencing around these transitions from wall to roof, this is what it may look like at at where the roof meets the wall with your existing house wraps. You're just having to do lots of taping and sealing around it. Very possible you could get passive house levels of construction, just a lot more detailing goes into it usually. Here showing taping around the rafter, but still venting above the vapor permeable roofing underlayment. Here it's showcasing our Mento Plus I think they actually dense packed through this on their for their roof system. But you can see that above this strapping, there's a second layer of decking, and that's placed there to put their finished roof to be installed on. This helps maintain the drainage and ventilation plane above your vapor permeable roofing underlayment while preventing penetrations through that underlayment. So if you were to install your finished roof directly on this, you'd be introducing a lot of air and water leaks. So this prevents that while giving you a dedicated plane to dry on. Because as we're using new vapor permeable, watertight, airtight roofing underlayments, we want to allow a channel or airspace for that vapor to dry and dissipate through or condense and drain out. If we had like a finished metal roof directly on this, that's a condensing surface. And if you don't give it a space to run off or drain effectively, since these are vapor permeable materials, there's always a risk of inward diffusion, which is why I'm always recommending with all of our systems, wall and roof, what we call a vented rain screen approach. And this should be pretty familiar to most of you guys for what you guys are currently doing with your range screens and whatnot. On the roof, it might not be as familiar if you guys are subbing out much of your roof install, as I've seen many larger roof installers that maybe do metal roofs and stuff push back because this is new and they're used to their vapor closed ice and water shield or just vapor closed systems. This allows for a bit more of a dry building in that way. So some projects are transitioning their interior air barrier for the roof, if it's an unconditioned attic or if you're venting below the sheathing, and that is touching the framing. So you can see floppy bits running to both sides of the wall to tie into later. Same concept we did for floors, but they're pinning it between their top plates for their walls, so they could tie their exterior house wrap in on the outside to their interior ceiling air barrier. If you guys saw when the meeting started, and I think on Tim's project, he had this detail showing his zip on the outside, tying to his ceiling air barrier on the inside. So it's a detail I see used often, and it works very well. So this is the transition we're talking about from exterior membrane to interior air barrier, which is Intello Plus in this image on the right. So we would be venting below the roof sheathing, and the eaves would need to keep their air barrier continuous and complete. So we need to transition to the interior air barrier for the roof system since we want to vent over it. So here you see we're topping the top plate with a wide piece of Tescon Vanna tape or membrane to connect to this exterior air barrier on the wall and the interior air barrier on the ceiling. Just because if you were relying on your roofing underlayment being your air barrier at the roof line, if you're venting, it becomes very complicated on how you make that transition while still allowing airflow. Basically impossible. So you would need to go this route essentially. But this is great because we're always recommending in most climate zones Intello Plus or a smart vapor retarder on the ceiling. Heat rises, you're going to get a lot of your accumulation there, and that's where you want vapor variability. So in the winter time, it can close up to be a class 2 vapor retarder. Moving towards the summer, it would open up and be vapor permeable. And this is just showing that top plate connection that makes that transition. Again, I'm pushing people to use a tape or a membrane. We have a video that I just posted on Instagram on our 475 page, which shows how to make strips out of Adhero. So if you want to use it like a tape, you could get more cost for coverage out of a big roll. It's a little jig system I helped come up with, but very useful and makes for a real robust connection. What's great about the Adhero when used as a tape is that it's not only airtight and watertight, but permeable, but it is also self-sealing around fasteners. So you don't have to chase this and worry about if you're putting other fastening members into this, that you're creating air leaks and burying them in framing. And this is why I love this so much to be used as a roofing underlayment and as a WRB for your walls. It just is a lot easier and quicker for first-time installers because it just presses on, sticks on, and then does not require a tape or anything like that. Real simple system. And this is showing our Intello Plus membrane inboard of the insulation for the roof. You can see where the Intello comes down to connect to the subfloor. They've taped their subfloor seams to make their subfloor an air barrier, and they're making that connection from Intello to subfloor with a piece of tape or with our adhesive. Something I want to note is that all those patches are dense packing holes, and they've actually included a service cavity to protect the interior air barrier and run those utilities. So especially if you're dense packing your walls, you want to protect that membrane given that it's holding all that insulation in. So, if any of you guys have kids and they might have put an elbow or a shoulder through the drywall, I look at drywall as a protective, or what I like to call a sacrificial layer. It's there, it looks nice, it's your finish, but it's made to take the brunt of force so your Intello doesn't have to, or your interior air barrier doesn't have to. So as a homeowner, if you're building this for yourself or building this for a client, your homeowner doesn't want to need to think about if they want to hang a photo on one wall to another. They don't want to have to know what's in their wall. They shouldn't know what Intello is. They should be able to hang their photo. This prevents that penetration from reaching their Intello membrane. Same concept with TVs. Same concept with kind of all penetrations through your drywall. It makes the penetration at the face of the drywall and not at your actual air barrier, which should maintain airtight, continuous, and untouched. And lastly, we're verifying all of this with a blower door test, which I hope many of you guys are familiar with and are doing at multiple stages in the construction process to verify the airtightness of the envelope. I'm giving these tests very often. It's real cool to see when you've gone from one stage to the next, from exterior sheathing, windows to interior air barriers, to just see that that ACH value just plummet. It's real great to see these work in practice and see the verifiable results. It's why I love to blower door. We're 475, we're an e-commerce website. Visit our website. We've got an incredible amount of resources, almost overwhelming. So if you do have questions or specific things you want details on, feel free to reach out to me because I could point you in the right direction if you get lost in our many resources between our blog posts, our how-to videos, or things like this. Also, just so you guys know, on our website, it's called the Smart Enclosure. It's a free to download ebook. We have 7 different assembly types that go through walls, floors, ceilings, kind of a lot of the details we talked about today, have them in DWG and CAD files so you guys can use them on your own time. And lastly, just want to say thank you very much for having me out today. It's been a pleasure. And if you guys have any questions, there's my email, my phone number. I'd be happy to work with you guys. Thank you.
Thank you, Ben. That was great. Lots of good information in a short period of time.
Yes, I tried. It's funny. I tried to squeeze in as much as possible. In the beginning of the presentation, I note our 475 building blocks. This actually is an hour-long talk we've given. It's recorded on our website. I've just tried to condense it as much as possible. So if you want to know more that gets more nitty-gritty into building science and stuff like that, check out our YouTube. Our senior product consultant, Nick, does a fantastic job of digging into it. It's a multi-part series. We've only had 2 or 3. Part 1 is about high performance windows and window install. Part 2 is about tricky transitions, and I believe part 3 is some more of that, but different details on the structure. So
Yeah, those YouTube videos are fantastic. I was just watching a concrete-free slab
yep,
one this morning.
fantastic. Yeah, I've had
Yeah,
the pleasure to be on 1 or 2 of those projects myself, and it's interesting. Those floors actually have some spring to them when you go
yeah.
slab to slab, so it's interesting. I encourage you guys to try to get out to one if possible. Try to reduce carbon. So.
Howard, you have a question in the chat. You want to ask it?
Sure. Yeah. When we are talking about these subslab vapor barrier and radon barrier, what do you do when you have an ICF foundation instead of a clean concrete wall to tape it up against?
Of course, yeah. So, well, I guess it depends on what your run wants to be. If you're setting it on top of Stego, you can run it under the outside. But typically, what I'd be seeing done, honestly, is running the Stego long up to the top of that foundation wall, and then turning to the outside. So still reaching the top of that sill wall, but it's just, yeah. Then your Stego on your basement floor or your slab floor becomes somewhat of a wall membrane. But that's a detail where you don't need to use Stego. You can use another airtight material like one of our other membranes to transition over that wall. But that's a good question. And you might be even treating it with a liquid applied to then stick to. So show it's a continuous, sealed up surface.
So you would run a Stego, even if this is a fully underground basement with full height walls, you would run a Stego up against the ground to be able to seal it on top of the concrete?
Correct. Yeah. And I would be able to, I mean, I would definitely want to see a detail. If you want to email me after, we could talk about it in further depth. But off the top of my head, that's what I would think you'd do until I see something, in a drawing.
Interesting. Okay, thank you.
Howard, I can tell you, I've never done that. I've just terminated the stego against the ICF, above it sort of baseboard area.
Yeah, that would be perfect.
Because in my opinion, that's airtight and vapor tight enough. What you get there with that foam layer and the concrete right behind it, I haven't seen any issues on past projects with that approach and have not covered ICF. I mean, you could certainly look into that more, see what benefits that may provide. In part because when you have a basement, they're going to run some electrical, maybe plumbing or something through that foam layer. So you'd be hacking around in that again. Potentially, you can always do an installation service wall, of course. But yeah, on the basic projects, I would say we haven't done anything. We just come up 6 inches, a foot, something like that, terminated, and leave it at that. And then where it transitions to a bottom plate, you can seal it right onto the bottom plate of the framing too. So if you're looking for that transition, and that's where these tapes come in.
Yeah, I completely agree. What I'm worried about there is just more the air seal than anything else. So like Tim said, you can get that through the multiple layers of foam, the brick wall, and that termination to that, or not brick wall, concrete wall, or that termination to the bottom 6 inches, like he said. So.
Yeah, that's kind of what I expected, but I wasn't sure if there was any way to kind of eliminate the risk of something seeping through between each block.
Yeah, I have a project that this is, again, kind of like as Tim said, you don't need to go that far because I haven't seen issues like this in the past, but I have a project that's actually running one of our Adhero exterior house wraps that's fully adhered. They're using it as an air barrier to transition. They're not doing ICF, they're doing foam board on the interior of the foundation wall and taping the seams. They're just covering the whole thing in one peel and stick, sticking it to their stego, and then transitioning it to their top plate. But I don't think they would need to do that, but they want to, and I'm curious. I want to get on site and see it because it's a cool detail. But yeah, not something I'm pushing people to do very much.
All right, thank you.
It's just real quick. I put up a slide with some useful links. If you're interested and want to write any of those down, or feel free to push that over to the site, and we can continue with some Q&A here with Ben in our last few minutes. If you have any more questions, feel free to just speak up.
And I just want to make a note to all architects or builders or really anyone in here that I am commonly helping with takeoffs and estimates. So if you guys have projects that you're just curious about what it may look like to go with this system, I'd be happy to price that out, get on a call with you, talk through your details, and help sequence where things would go and why. We're very hands-on as a company, so we'd be happy to help out with whatever you guys are working on.
I'll chime in with another comment because I didn't see it in your presentation specifically, Ben, and it might mean you sell a little less product, but I've always been a big fan of using the structural sheathing on a framed wall as my air barrier and vapor management layer. And I love how you talk about how there's a difference between products that are airtight and products that are designed to be airtight. Like many practitioners, I found that out the hard way too, using OSB straight up and then learning that OSB is full of holes. Although never enough to kill a blower door test. But I think that as a system for our cold climate is attractive because more often than not, we do end up with a significant wall thickness and a double stud type of scenario. And you talked about protecting the air barrier from anybody, shooting holes through it, putting nails through it. And there's really nothing better in my book than using the structural sheathing on a wood frame wall for that purpose, because it's 3.5, 5.5, 7.25 inches back. So the risk of that being damaged is near nil. And then where your products come into play is the Band-Aids, which you didn't show specifically today. So check out their website, but they make these I call them Band-Aids that are basically management patches of a self-adhering product that you can then shove cabling through, plumbing through, and things of that like. That can be super helpful there. It's just another system that Ben didn't show specifically that I think is attractive in our parts. Wherever you need multiple plies of wall, that's another way to look at that. And then you use the tapes and to make the transitions exactly the way he showed it, with the flappy bits at the top and maybe the bottom and some caulk, and you bring it all together. I just wanted to throw that in the mix because to me, that's been a very good system here locally, one that builders understand, and that gets you out of the hole of having to wrap an air air barrier, you know, in and out and around stuff, because you're really just taping the outside of the structural box.
Mhm.
And that is very easy to explain to people. And if you set your windows flush with that, then you can imagine that also becomes very easy to connect a window into that system. So I wanted to put a plug-in for that. It's not anything
That's great.
proprietary, but it's a good working system.
Yes, yes. I do want to also piggyback on that. I agree with Tim. That is great. I actually see a lot of projects in my climate relying on the structural sheathing to do that because of how thick these walls get. I was on an I-joist outrigger project where they're doing all the sheathing inboard. The wall is like 17 inches thick. It's a very thick wall. So it just gets very tricky with site conditions, how much room you can build out to. But what I wanted to showcase is for just on our website, one of our many resources. This is our how to air seal air barrier penetrations, and it's just showing some of these gaskets that Tim was referring to that are just patches. They're essentially some of them are just EPDM with tape that we sell and that are cut and pressurized to fit, but we do have some ones that are embedded in tape.
Hey,
And
Ben,
then this is
do you have
showing.
do you have something on your screen you're showing right now? Because
Oh,
we're
I
not
did. I
seeing it.
didn't know if it was showing. It says I'm sharing.
Yeah.
I realized I
I
wasn't.
can see it over here.
Can you see it now? Oh, okay.
I
Sorry.
can.
Oh, well.
Never mind.
Well,
Good.
no worries. Yeah. So yeah, this is just showing some of the methods and just kind of gives you a plan of action depending on what scenario you're looking into. So if you weren't going with a service cavity, this is what you might have to do to, seal around your outlets and whatnot. So this is locating the air seal at the back of this box rather than at the actual electrical box. So it's a cool detail which allows your trades to come in later on and install their stuff, and they don't have to do the air sealing. So depending on who's installing it or when, there kind of is a plan of action, but this is just kind of showcasing without a service cavity how you could approach something like an outlet because it is, lots of taping. But yeah, we've got lots of blog posts like this that are different how-tos. This is they're all quick links to get to the pages, all the sizes. And yeah, and if you guys have any, further questions, feel free to shoot me an email and I'd be happy to talk further in depth on a call.